Hi everyone, welcome to Math Moment with Mr. Dustin. I'm Mr. Dustin. So today we're going to be looking at area and how to calculate the area of different types of figures. Now this is normally a concept learned in a geometry course. It's also covered in some middle school courses. So if you're anywhere in that age range, this is kind of where or what you would be learning in your classes. But if you're outside of that age range, then you can still take a look. It could be a great review or a great preview either way. So at the end of this video, there will be a formative assessment, or at least a link to that. The link is in the description. So if you could take that for me, that would be great. It would be nice to track your progress to see how you're doing. So enjoy the video. All right, today we're going to go over area of different figures. So the first figures we're going to look at are rectangles and squares. So the area of a rectangle and a square is length times width, and that refers to each of these side measurements. So let's look at this first example. We have 5 and 4 as our length and width. So we'll multiply 5 times 4, which equals 20. So the area equals 20 centimeters squared. Now, why is it centimeters squared? Well, when you multiply centimeters times centimeters, the units become something like centimeters, which we simplify to centimeters squared. Like when you multiply one thing by itself, you simplify that to that thing squared. 2 squared equals 4, or something like that. Speaking of square, let's look at this square. So 18 is the side length and the width. So we'll multiply 18 times 18, which equals 324. I had to use my calculator because I don't know that off the top of my head. So that means it is 324 inches squared. And this can work with any unit. You can make any unit squared. Now, why do we want units so bad? Well, it's because there's a big difference between inches and miles. You want to give the right unit of measure so people know what you're talking about. Let's look at some parallelograms now. The area of a parallelogram is base times height, which is similar to length times width. It just refers to this bottom part and the actual height of the shape as you see it. So let's look at the first example. This would be the base. It could be the bottom or the top, by the way, because they're the same length. And then this is the height. Notice we don't care about this diagonal. We don't want to use this because it's not really the height of the shape. So let's see, 15 times 8 equals 120. I had to use my calculator again. So that makes 120 inches squared. So now we'll go like that. And let's look at the second example. So we have 7, 15, and 5. Well, we know that we don't like these diagonals, so we can eliminate 7 here. So we're looking at 15 as the base and 5 as the height. So we'll do 15 times 5, which equals 75. And then that means the area of this figure is 75 centimeters squared. Just like that. And those are parallelograms. Now, one interesting thing about parallelograms is if we take this dotted section here, this triangle, and we move it over here, it becomes a sort of rectangle. And that is why it is still base times height, because you just form a rectangle again, although you don't see it as a rectangle. So that is why we calculate area like that. It's pretty interesting. So let's move on to trapezoids. So trapezoids, we take one half A, which is this top base. So you could also call that B1 plus B, which is this bottom base, also known as B2, and multiply that by the height. So let's look at this first example. We have a base of 20, base of 30, a height of 12, and again, we don't like this diagonal here, so we're not going to use that. So let's see, we want 20 plus 30 times 12 over 2, which gives us 300. So the area of that figure is 300 centimeters squared. Like so. And let's look at this other trapezoid. This time they didn't give us any useless information, which is kind of nice. So we know base 1 is 15 plus base 2, which is 23. We multiply that by 9 and then divide it by 2. So 15 plus 23 is 38, and then multiply that by 9, we get 342. Divided by 2, we get 171 is the area. And this time we don't know the units, so we'll say units squared as an arbitrary unit of measure. And we just want to make that distinction that it is in whatever unit, squared, as opposed to just regular units. So those are the trapezoids. And now we're going to go into a break. So enjoy the break, and we will continue with some more shapes after that. All right, so for the break today, I went to the beach and there's water and it's high because it's high here. So just to illustrate area a little bit more, I'm going to draw a triangle. We'll learn about triangles in the second half of it, but the area of this triangle is 1/2 base times height. Now, why is it 1/2? Well, if you were to put another triangle right here, you can see that it makes a rectangle, and that is base times height. So this triangle is half of it, and so that's why the formula is 1/2 base times height. So yeah, that is the little prank for today. I think I'll take a swim because it's really nice and warm outside. So yeah. Hi everyone, welcome back. I hope you enjoyed the break. Let's take a look at some more examples of area with some different shapes. So first we'll look at triangles. Now the formula for the area of a triangle is 1/2 base times height. So base refers to this bottom area here, which this figure has labeled for us, and height refers to the vertical stretch here. So in this first example, right over here, we'll be looking at 3 as the height and 4 as the base. And notice they give us 5, but that is not essential information, and so we won't be using that for this type of problem. Now, we'll have to multiply 3 times 4 and then divide that all by 2. So 3 times 4 is 12, and then dividing that by 2, we get 6. And now notice we don't have units here, so we'll just put it as an arbitrary unit. Remember, it's units squared again, because units times units. Let's look at the second figure here. So this time we're given several different measurements. So let's identify which is which. The 14 is pretty obviously the base. But now, which one is the height? Do we want the 12, the 5, or the 6? Well, the 12 is the hypotenuse, similar to our 5 over here. So we don't want that. And then the 6 is also kind of a similar situation. So we actually want the 5 here as the height. So what this means is we'll be multiplying 14 times 5, and then dividing that all by 2. Now I don't know that off the top of my head, so I'll use my calculator. 14 times 5 is 70, and divide that by 2, we get 35. And again, we don't have units, so units squared. It's important to remember to label your answers with units so that you know what we're talking about. There's a big difference between inches and miles, so you don't really want to get that confused because that could be really bad later. So let's look at the next shape, kites and rhombuses, also known as rhombi. It can go either way. I actually looked that up to make sure. So we'll look at the kite first. Now the formula for both of these is x times y over 2. Now what this means, x is a diagonal, meaning this portion here, and y is the other diagonal, which is this portion here. So the length of this entire diagonal is 10, because 5 plus 5 equals 10. And then the length of this one is 20, because 5 plus 15 is 20. So what this means is we will have 10 times 20 over 2. And that is equal to 100. So this will be 100 inches squared. That is the area of this kite. And now we'll look at this rhombus here, and we're looking at a similar situation. So 16 times 12 over 2. That, let's see, 16 times 12 is 192. Then divide that by 2, we get 96. 96 centimeters squared. We can tell that based on the units they gave us. So what distinguishes a kite from a rhombus? Well, a kite has 2 different lengths for its sides, and these 2 up here are the same, and then these 2 down here are the same. A rhombus has the same length for every side. So it's kind of like a square, but tilted, like a parallelogram, if that makes sense. So that's the difference between them, but you find the area the same way, which is pretty cool. So let's move on to the next thing. Circles, this is the last one here. So the area of a circle is pi times the radius squared. So for this first one, we notice that the radius is 7 inches. So we'll just do 7 times 7, because that's 7 squared, times pi. Now that is equal to 49 pi inches squared. Now, if your teacher is looking for a decimal approximation, I mean, you definitely have to put it into your calculator. So I'll give you the decimal approximation, which is 153.938. And I'm just in the habit of rounding to 3 decimal places, but you can round to whatever you're supposed to round to. If it's 2 or 1 or none even, 4, either way. So these 2 answers both work. Well, 49 pi is more precise, 153 and all the rest is more of an approximation. So, but both work. So let's look at the other one here. Now notice they gave us the diameter this time, which is 36. We don't want diameter because that's not in the formula. We want the radius, which is half of the diameter. So what is half of 36? Well, that is 18. So we'll be multiplying 18 times 18 times pi. And so that will give us 324 pi feet this time. This is the first one in feet we've had, squared. Now the approximation for that is 1017.876. Again, both of these answers would work for this circle. So those are all the areas. So yeah, I have another formative assessment for you. The description is in, or sorry, the link is in the description. So feel free to check that out. And yeah, thank you for watching this video, and I hope you learned something about area. We'll see you next time.